Good afternoon. Today's video is going to be about how to use MultiSim to run some simulations. And when you do that, you can test some circuits. You can do a little bit of homework. You can do labs. Now that we're online, you may not have as much access to actual real-world equipment, but there's a lot you can do with MultiSim. And in a lot of ways, it's pretty similar to the real-world stuff. So let's start. I've kind of created this circuit in MultiSim here that I'm going to run some simulation on and measure the voltages and currents. But before I start, I want to point out that you might look at my setup here, and my menus are going to be a little bit different than what you have. Over the years, I've moved things around and discovered new things. So don't go in a panic if you can't find things. If you click on the main menu, it'll drop down a big list of things and menus that you can add in. So this one is the main. So if I click that in, it brings up this main menu button area. And to me, that's the, some of these things I don't use very often. And I've also fallen into the habit of using the drop down menus. And so I've just removed the buttons because I never go for them. You may find that you work different and you may want those menus. So the menus that I've got up here, I've got the simulation menu. That's this one over here. This is the probe menu. I use that one a fair bit. This is the instruments menu. This is the zoom in, zoom out. It has a button on here where you can do full screen and you can zoom the schematic up to fill the window, which I like. And I've just put this one up here today. This is my sources, so I'm going to try to use that one. That one looks to be useful. Usually I grab components from the component database, but sources and things is something that you're grabbing all the time. So I thought that I would drop this menu up here and see how that goes. You can lock the toolbars when you're finished. It's down here behind my back. So then I can lock it and then they don't move around. So here I've dropped down a circuit into MultiSim. And I want to see how it works. So the first thing you need to do is that when you want to test your circuit and see what the values are, you're going to have to run a simulation. And then if you come up here and you press the run button on the simulation menu, it will now start running the simulation. Sometimes this comes up with an error and you got to play with things to get it to work. That happens rarely. Don't worry about it till it happens. So here I've put in a simulation. And now the simulation is running. And one of the things I can do is I can go up into this probe button menu area. I can drop down a probe, and then the probe will tell me what the values are at that point in time. So here this is a V probe or a voltage probe, so it's testing the voltage at that point. I can double click on this, increase the size of the text so we can all see it. So here's our probe. So it's telling me it's 10 volts. The peak-to-peak voltage is 0, which means it is not time varying. It's a constant voltage at 10. The RMS voltage, this just says 0, so that means that's the AC voltage. So it's 0 volts AC and 10 volts DC, and it has no frequency. So the voltage probe gets you a couple of things there. Let's drop down a current probe. So over here, I'm going to put down a current probe, make that a little bigger. So it says it's 2.5 milliamps, peak 0, RMS 0, so it's not changing at all. It's DC, 2.5 milliamps, DC. Does that make sense? Well, let's just see here. I got two 1Ks in series. That's 2K parallel with a 2K. That means this is 1K. And there's now 2K and there's 1K. There's 2K. Basically, 20 volts and 2K is 10 milliamps. 5 goes there. 5 goes there. 5 milliamps coming into this node here. 2.5 goes that way. 2.5 goes that way. This point right here should have 2.5 milliamps, which it does. And if I put another voltage probe on this point here, 2.5 milliamps through 2.5 milliamps through a 1 kilo ohm resistor should result in 2.5 volts. This is the other thing I like about the probe is you can move the probes around and you can kind of position them so that they're out of the way and don't block what you're looking at. So if I wanted to move this guy down over here, I could click on this guy and I could rotate it. That's a Control R. And I could kind of maybe do something like that to tidy things up, and that would make a good cut and paste. So there's kind of the DC probes and how you can use it to analyze a circuit for DC. Now another one that you can use, there's a couple of other instruments that you can use. I'm just going to delete this one off here, this one here, this one here. I've also got the instruments bar here, but I'm going to have to stop it for that. So I've stopped that. I can plunk down a multimeter and I can hook that up. I'm going to copy this ground probe, put it over here. So there's a multimeter I've placed down. I'm going to double click on it. That brings up the current value. Press play. So basically that's 2.5 volts. This is a voltmeter. So if I put it into amps, it's going to say it's 3.81 milliamps. So what has happened here, if I apply a DC meter to this point here, a current meter, it's a low impedance past the ground because a current meter is essentially a short. Current meters are usually put in series. I've put it in parallel with this resistor. So when I turn it into a current meter, it shorts this point to ground and all of the current dumps through there. It changes the circuit. No longer 2.5 milliamps. It's now 3.81, probably 3.8125. So basically I've put a meter in the circuit using it incorrectly and I get kind of a funny value. Go back to a voltmeter. Voltmeter is an open circuit, so it would be no load and we would get 2.5 volts there. So you can measure amps, volts, ohms in decibels, and you can measure AC values or DC values. So in order to change things, if you want to modify a circuit, you have to stop simulation, and then you can go in and modify the circuit and then rerun it. I'm just going to crank this out here. The other thing that I found here recently was the measurement components. So this is another set of measurement devices. So here is an ammeter. Place horizontal, it says, so I can drop this ammeter down in here. Like so. Close that box. Press play. 2.5 milliamps, exact same value we got with the other one. Actually, we got 2.5 volts with the other one because I was using it as a voltmeter. So here's an in-series current meter from that menu bar, and I'm going to stop that. If I go back to this one, if I want a current meter, I got to put it in series, like so. Run the simulation. Double click on this guy here, put it into AC current mode, 2.5 milliamps. So there's how you can use the simulation, starting and stop a simulation, and the measurement tools to measure a DC circuit. And I think I'm going to start another video to do the AC so that we keep the videos short.